Welcome to Azure Back to School. Today we will talk about IoT Central for any extensible project. First of all, I would like to introduce myself in order to clarify why I will talk about IoT. I work with IoT solutions from more or less 15 years, and from 2015 I use only Azure Platform as a Service solution in my work, in my daily work. So today I will talk about how to use in a professional way and in a complete way all the features regarding IoT Central. This is the agenda. We will cover 4 topics. The first topic is about IoT Central itself in terms of context, pricing, and standard functionalities. Okay. After that, we'll go deeper into the architecture of communication between IoT Central and IoT Edge as a sort of extension of IoT Central at the edge. And so we will talk about IoT plug and play, DDTL, and so on. The third topic will be about extensibility. So how to connect IoT Central to other services such ADX, SQL, Logic Apps, Power Portals, and so on. The fourth topic will be about how to manage solutions with the IoT Central and how to plan and develop solutions starting from IoT Central. Okay, this is the scenario. Okay, so the mission, the vision, and how is positioned IoT Central in the Microsoft view. Okay, so the mission is to simplify. It is obvious. You have simple service configured as a software as a service, and without any development capabilities, you can build up an entire solution. The vision is regarding the possibility to approach IoT in every kind of organization. When I talk about simplicity, so simplified topics, which are, the first one is how to connect things. So how to develop the structure of data in terms of properties, in terms of commands, and so on. And this is very simple, totally visual if you want, using the portal, the web portal. And after that, another important thing about simplicity is the possibility to build up interfaces, not only communication easily, but also the possibility to build up dashboards, horizontal dashboards, so a sort of cross-device view, or if you want, vertical dashboards that are linked to a particular device or a particular device model. Another important thing about IoT Central is its capability to be connected with other services, only configuring, so only using some web form in order to configure the link between the data stream that comes into IoT Central from the devices, and in order to configure it to come out and go in another place, for example, blob storage or a database and so on. Remember that security is a very difficult topic, and it is simplified with the IoT Central. So with this slide, what I want to say, I want to summarize how is composed an IoT extended pipeline. So think about that you've got a sort of IoT probes, so something that send telemetry, And probably all the device structure at the edge is not a one-layer infrastructure, probably is a two-layer infrastructure. So you have child device that are positioned in a network, a separated network from internet. They communicate with the internet using a gateway that is another layer of devices. And within that gateway, you can aggregate, preprocess, or create some derived value from pure telemetry. Probably in an extended pipeline, you have to preprocess data using a sort of dynamic set of rules in terms of limits, thresholds, and after that, you can send to the cloud your payloads. Those payloads must be sent using a particular morphology in terms of attributes. And in the Microsoft Word, that morphology is called DTDL, Device Language Definition, Device Twin, sorry, Definition Language. Probably even in the cloud world, you have to route and do something in order to send the data to the proper service. For example, you can manipulate directly in a sort of CEP, okay, so complex event processing, some value that comes from the field in order to drive some business action, for example, an alarm in order to open a ticket, okay? And probably you have to store all the raw telemetry in using another flow to summarize those data after a period. So in a sort of cold pipeline of a Lambda, in order to not only to archive data, but to analyze data within data warehouse, for example. And probably your IoT Central application must be connected to other applications in terms of API calls in order to reset a device, send a command, and so on. And probably in the Microsoft world, the best choice you can make is to use Power Apps or Power Portals. This is a Microsoft slide, I know, and you know, but I would like to clarify the message. So if you want to manage your own with all the complexity, a solution, don't use IoT Central. Use classical platform as a service solutions such as IoT Hub and so on. If you want to have a simple solution in terms of management, not in terms of functionalities, if you want to drive a business step by step without consuming too much money at the starting point, probably IoT Central is your best choice because it is very simple to build up solutions, and in a certain level, it is very comfortable. Okay. Third, if you want to have cost that is cut down device by device, and your device are not data intensive, please use only IoT Central, okay? Because using IoT Hub is equal to wasting money. Basic features. You know, within IoT Central, you can have many things that are already done from the product group, and so you have only to configure. So you can activate new applications. Remember that in every subscription, you have a limit of 10 applications. So you can manage device sets, so groups of devices. Now you can manage organizations, so multiple customers within the same solution in order to make a multi-tenant solution. You can manage, obviously, with the versioning device templates. You can simulate devices. It is a very huge commodity for developers. And in order to manage all your fleet, you can manage using scheduled jobs. And so you can start a workflow for example, maintenance, dynamic dump of logs and so on. And you can see how it is going on using a single command. The most important functionality within IoT Central is rule and actions. So you can configure rules regarding your data in terms of arithmetic rules, Boolean rules, and so on. And the reaction is to build up a payload with a trigger. So the rule ID, the device ID, and the current value, the threshold, and send this payload to a workflow. So, for example, to a logic app, to an event hub, and so on, to a queue, other things. Remember that you can compose your own dashboards. And recently they add a functionality. Um, so you can import within a tile, so a sort of piece of page, external content. Okay, so for example, you can embed other things, Power BI, for example. And the last, but is the key functionality in order to extend IoT Hub, IoT Central, is the continuous export functionality. And so with this feature, you can configure a continuous stream of data that comes out from the IoT Central and go outside, so files, databases, and so on. And so some of the functionalities is seen as a sort of advanced feature. For example, the continuous export is um, an advanced feature because it permits to link and go on with the data trip, okay, using Synapse or using a data lake, and after that Synapse, for example, or use queues in order to have a reliable solution in terms of, for example, alerts that can be managed separately from IoT Central, or topics in order to distribute messages to multiple services. And the last one is the file upload. So with this functionality, your device can upload, for example, logs, or dump to the cloud using IoT Central files. With this simple solution, with this simple feature, for example, you can dump out all the raw telemetry and so use IoT Central only for alerts, alarm, and state changes, and so on, health checks. But all the raw telemetry can be sent to the cloud in a file, and in order to put the file into a storage, and then with the on file created trigger, okay, you can manage with the event grid or ADX that file in order to be acquired, and so on. This slide represents the real 5 steps, in my humble opinion, to use IoT Central, not as a toy. Many people think that IoT Central is a toy, and they are wrong. The first rule is to learn the fleet management mindset. The mindset is to keep in mind that if you do something wrong, you lose the device. And so you have to pick your car and go to the device in order to reactivate, reset, and so on. So pay attention with devices. When you do things, you have to keep in mind the firmware version of a device, test all the functionalities with in your laboratory, and then you can deploy with the job your commands or your upgrades triggers. Another important thing is to standardize the brownfield. What I mean, you know that in the IoT world, you have two kinds of devices. The greenfield devices, so the things that can be connected using MQTT's protocols, and so they can have a sort of persistent connection with the cloud. But you have got a plethora of brownfields, so all the devices that cannot be connected all the day to the cloud, and so they are called ephemeral devices. And with this kind of device, you have to have another approach using, for example, HTTP calls, and think about that with the IoT Central, you can manage a sort of particular endpoint for this kind of devices. And that endpoint is called device bridge, in order to have a sort of HTTP endpoint to acquire data that is sent with the device morphology, that is another morphology, and behind the device bridge, you have to put your own logic in order to convert the data. Okay, if you can, please do that things at the edge, and so send a DTDL compatible message direct to the device bridge in order to go directly after the device bridge to IoT Central. Third, build apps for people. So every kind of people must have its own list of functionalities. Okay, different people must not see the features of other kind of people. So the maintainer, the operator, the sysadmin, the developer, the solution developer, the device developer, and the solution developer has got different ways to manage the same data. And so please build apps using this approach. Okay, don't think to one person, but think to multiple person and build up the solution for every single kind of person. Fourth, if you can, extend your application using other Microsoft things, for example, Power Portals. Avoiding custom apps because when you start to use IoT Central, you start to use that service because you want simplicity and you want to be rapid and so on. Okay, if you want to go quicker, please continue to go quicker using, for example, Power Apps or other things, in order to avoiding customizations for another business steps. The last step is to implement monitoring and security compliance at the first stage, because if you pursue your solution without thinking to monitoring how to monitor devices lost connections or device errors, and to address any kind of issue within internal ticketing workflow, okay, you will lose the control after 1 hour of production. Okay. When you use IoT Central, you have to deal with a particular thing. This particular thing is that IoT Central is updated every month. And so every month you can have new functionalities or the retirement of some feature or deprecation. Okay. So please keep attention and think that a small part of your daily time is to manage these changes. Okay, so when you build up a solution on cloud, you know that that solution is not a static solution because the cloud changes. Okay, think that IoT Central is more rapid to change itself. And so, for example, in my opinion, these are the most important updates regarding IoT Central. The first one, as I said, the support for building multi-tenant solutions. So you can have the possibility to divide your devices into organization. And so you can deliver solution profiles, for example, device operator, okay? So the man who monitor the device connectivity for every single organization. Um, Another important thing is to monitor the edge part. And so recently, you can, they added the functionalities in order to monitor in the standard way, so using log analytics and Azure Monitor, also the IoT edge devices managed. And another important thing is the responsive UI. And so you can use IoT Central even with your smartphone. Another important and funny but very important feature, let me double check on my iPhone. This app is connected to Azure IoT in this moment, sorry. This app. With this app, you can use as a sort of test device with the accelerometer, gyroscope, magnetometer, barometer, or obviously battery level, geolocalization, the possibility to edit properties, so writable and only read properties, and the file upload functionality directly from your smartphone. So you can use a sort of IoT plug-and-play device in order to test your solution using your device. It is very, very funny but important feature. As I said, they added the possibility to embed something, some HTML that is coming from another website into a particular tile of your dashboard. That is very important in order to include external things. Probably the next feature will be the possibility to consume APIs from externals. I hope so. And the last one is the generally available APIs in order to create and manage all the entities within IoT Central. So groups, organizations, device models, and so on. After this brief introduction, not so brief, I speak about IoT Central service overview. Okay, so that is very, very rapid way. In IoT Central, you can have device connectivity management, so device template model, device sets, telemetry ingestion, and command and control. So you have for every device model, you can set up properties that can be synchronized with the edge. And so you can synchronize properties such configurations, okay, in the device configurations or set points. And you can have a sort of additional interaction with the device, sending to it some command. Okay. You have all the rules and the action section. With the admin view, you can perform operation in terms of permissions, so user profiles and so on. And dashboard visualization insight, and all hosted by Microsoft. So you will see only one icon in your Azure portal about the IoT Central service and nothing else. I would like to point out a simple assertion about users. Think to users in terms of responsibility, work responsibilities. And so, IoT Central Product Group already know this assertion. In fact, they plan all the user permission section using this approach. So you can have a sort of four profile division in terms of work responsibility or journey. Okay, so you can have the device operator. The device operator deals with the device connectivity, and device telemetry is not covered by him. So he has to send the telemetry, yeah, but his needs are regarding the possibility to configure how to send telemetry, how to receive commands, and not about visualization or KPIs or last known values and so on. So the device developer must have its own dashboard in terms of connectivity, good or not, and a sort of KPI regarding the models that are deployed within the fleet. But it doesn't deal with data meaning. The second one is the system administrator, and so it is a sort of classical ICT profile that must deal with only user and permission section, and so with how many user of one kind or another kind, but he doesn't need anything about data visualization. The third one is the most complicated, in my opinion, profile, the fleet operator. And the fleet operator doesn't manage the data that is sent, so he doesn't know the meaning of the data, but he must have the complete control of the fleet in terms of errors, issues, connectivity, and versions, possibility to ask logs. So ask to with a command in order to have a file upload from the device into a particular storage and so on. And so it can the principal need is to deal with devices in terms of communication and in terms of health. The fourth one is the solution builder. The solution builder, at the opposite, doesn't deal with device connectivity. So a solution builder thinks that all the devices are okay, nothing else. And so it deals with last known values, KPIs, telemetry analytics, and probably data export to other things or rules in terms of distribute the data outside. For example, the fleet operator uses the rules in order to open tickets regarding devices. The same rule can export the message to a particular queue from if you think to the solution the solution builder. Okay, so fleet operator, device, solution builder, data from the device. When we think about the device connection, we have to divide all the data flow in families. So the first family is telemetry. Telemetry is the raw data. For example, the process control data of a machine, and is sent to by the device, is sent to the cloud, and telemetry can be seen as a sort of streaming data if you use the classical way, so use the IoT Central MQTT based data flow. And if your device send not too much data, you can use this way, the telemetry pipeline. If your device send a lot of data, think to file upload usage. But if you use this way, okay, is a very comfortable way, and but remember that you can do any rule regarding the telemetry flow, because the telemetry is not sent to the IoT Central, but is sent to a storage, okay, that is formally separated, linked to IoT Central, but separated in terms of data manipulation. Properties, so you can have three kinds of properties. The business property, for example, the owner of the device, this is a business property. You can have device properties, for example, the set points. These device properties are synced with the device, and the device needs these properties in order to make something. For example, a set point of a temperature. The third is the generic property, okay, and it is a sort of other thing that can be reported to the device, and the device can use this property to do some algorithm, or to do some check, or to do some filter. Commands are remote operations that are governed by a central point, for example, the reboot. This is the most huge argument when you talk about IoT Central. So, in my own experience, I found that every time is a new time to think about how is the message payload composed. And this is wrong, because if every time you do an IoT project, you remanipulate the morphology of a message, think that in the word, how many morphologies you can have. So one of the most necessities in the IoT world is to standardize the morphology of the messages. Okay, and so in Microsoft Microsoft proposed the IoT plug and play format. So it is a sort of standard in order to connect a device natively to solutions, because every payload is compatible with any solution from the other side. And from this point of view, they are doing a good thing from my point of view. But in order to do that, you have to deal with device twin definition language, so DTDL. DTDL is a sort of language for describing models in device model, so how many attributes, how many properties, which are the commands that are acceptable, and also this imply the possibility to send from the device to the cloud payloads that are only compliant with this morphology. And in order to design the device template, you can do that in several ways. For example, directly into the IoT Central, you can have a fantastic form to be filled, and after that you can export the JSON. Okay, simple. Wow. Or if you want a more structured approach, you can create a device model using an IDE, such as Visual Studio Code. And in this slide, you can see the DTDL editor for Visual Studio Code. And that's it. The other important thing that is recently changed for the third time, I hope this will the last time, in IoT Central is the export functionality. And so today you can export your data using several ways. So you can export to event hubs, service bus, QR topics, blob storage, or send the data to an HTTP external API. But the most important thing to be said is that you can divide into several exports your data types. So you can send telemetry, for example, to storage. You can send device connectivity to a webhook in order to manage externally when a device is connected or disconnected. Or, for example, you can export all the property changes as a sort of event to an event hub in order to be managed with a particular consumer after the event hub, and so on. Today you can customize UI not starting from the device, so selecting the device model, selecting the device, and then select which is the right widget to be used. Today you can add a tile to a dashboard starting from the UI, so starting from the visual. I want a visual, a pie. Okay, in that pie I would like to have two counters of positive health check and negative health check of my fleet, and so on. So you can have KPIs, so aggregated values, or over obviously over a time range, last known values reported, various kind of charts, line, bar, pie, heat maps. But you can have also histories, so list of the devices that are searchable, orderable, and so on. In terms of event, so telemetry, state, that is a sort of telemetry with on-off, and state chart is a good point in order to be seen, for example, a device when is connecting or not. and other visuals regarding properties, and also, obviously, the map telemetry. In this slide, I would like to put attention to how to make the correct dashboards for every kind of profile, okay, every kind of persona. And the right UI. Which is the right UI for the fleet operator? Fleet operator must have two kind of dashboards. The horizontal set of dashboards, so cross assets dashboard, for example, with the health check, device list with the last state and last known values. A sort of summarization, a pie chart of errors, or a pie chart of activities. Um, a, a dashboard dedicated to job monitoring. So how is going on the work behind a job that is running. And after that, you can think to the fleet operator with a vertical set, so device related, single device related dashboards. For example, one in order to view logs, not data, logs and alerts of the device, not data. Or another dashboard in which you have all the commands at your disposal, or uh, a dashboard with all the target sets. Okay, this is an example. So when you model the device, you have to think the set of dashboard for the fleet operator that are then when you deal with the device model. Okay, and after that you can have another set of dashboards for another profile. So the data viewer, so cross dashboard for what? Time series insights or analytics. So thinking to the data, not to the device. Or state changes of the device or telemetry for a device. Okay, in order to be an extensible project, an IoT project must imply the connection between, so the integration between IoT Central and other services, as we said. Which are the other services? Emails, webhooks, actions in terms of automation, so Power Automate, um, a simple set or not simple set of other Azure services. But how can you do the integration? You can do the integration using triggers. There are three kind of triggers. The first kind of trigger is the simple export. I export something that is triggerable from other services. For example, you export a file to a storage, and you can have the on file created event from an event grid, and you can have external services that are subscribed to that topic and then can react using that trigger. For example, usually I export the data to storage, and using Event Grid and Event Hub, I import all the telemetry into Azure Data Explorer in order to see and explore in the long term all the telemetry. Remember that IoT Central is a good choice for IoT projects, but it is not good for data retention, because you can have at maximum 30 days of retention. The second kind of trigger is regarding rules. So the action of a rule is a trigger. And so, for example, you can use direct connection with other services, or you can put the data into something, for example, using an API of Event Hub. And after the Event Hub, you can have a stream analytics that analyze those events and summarize in a window aggregation and do something calling, for example, a function, okay? Or putting the data into a database. So you can expand with the custom rules you can have an internal rule, and the action is in the reality the starting point of another rule evaluation, for example, in stream analytics. The third kind of triggers are APIs, obviously. So in this case, IoT Central is a passive endpoint. So externally, you can have a time trigger function that calls some API, or a time triggered logic app that calls some API within IoT Central in order to double check issues or device connectivity errors and so on. When we talk about integration, we talk about triggers, but which is the payload? The payload is this. So when you have, for example, a rule trigger, what is passed to the action is not the data, but it is that kind of payload. So in which you can find the rule ID. Probably you need an external service that calls an IoT Central API to have more information about rules by ID. Okay, but you can have the rule ID in terms of ID and description. You can have the telemetry that is sent and which is the threshold. So it is a sort of stamp of what is happened, and this stamp is sent away from IoT Central. Is there any caveat? Yes, there is a caveat. The caveat is this. Think about IoT Edge managed device. When you have IoT Edge device, you can have more than one module, IoT Edge module, right? For example, an OPC UA connector is a module, a filter is another module, other things. When a module send the data to the cloud, when an IoT Edge device, send the data to the cloud, the data is and the rules are linked not to the IoT Edge, but to the module within the IoT Edge. If you want to, for example, have a rule on telemetry that is in such way sent from different modules, you can evaluate this kind of rule because the rule is associated with only one module. Okay. You deal with the integrations, you deal with external services, and in this slide I put some icon in order to summarize which are the data flows between the various services of Azure when I activate event triggers or I use export to integrate data with external services. So, for example, when you deal with the event triggered process, external processes, for example, you can send from IoT Central some event to an event hub, and then you can use those events to compose new rules, new analytics, use streaming analytics. And as action endpoint, you can use, for example, Azure Function. Or, at the contrary, imagine that you can have a Power Hub. In that Power Hub, you can have a button, and that button can be trigger an event on event grid, and event grid can be connected even to IoT Central in order to call some API. So the connection is towards a webhook, and inside that webhook you can have an IoT Central API. Or from the export side, you can have many flows. For example, you can use a storage export to trigger some data factory copy activity or transform activity, or you can deal with Azure Data Explorer batch ingestion in order to import telemetry data. And after that, for example, you can use logic apps to make some custom query inside the telemetry data. Or the classical way, you can export all the events, all the telemetry events to an event hub, and use some analytics platform such as Databricks to analyze the streaming data flow. Central, we have to say several things. First one is that you have a maximum of 200 users per application, and keep in mind that data is retained on a rolling 30 days basis. Okay, so even if you have 3 pricing models, those pricing models are targeted to give you the simplicity to connect not data intensive devices. If you want, you can still connect data intensive devices, but you have to pay for extra messages that are billed less than millis per euro, okay, per message. And the first 2 active devices within the application are not charged. So you can have your application with, for example, 1 or 2 device for testing, and you don't pay for them. But keep in mind what is a connected device. So the question is, when have I to pay? When have I to consider connected to the billing model a device? A device that is registered and has completed the initial connection to Central is an active device, and so it is counted for the purpose of billing. Okay. So if a device has not been registered, but has not completed the initial connection, it is not counted for the purpose of billing. Okay. If you want to pay less for a device that is not more in use, you have to manually explicitly remove the device. So if a device is no longer in use, it must be explicitly removed to prevent it from being counted for billing. Okay, so the number of devices rise up when they completed the initial connection, but the IoT Central software doesn't know exactly when a device is removed, so is still active. And in order to not to pay for disconnected, definitely disconnected device, you have to remove explicitly. Okay. Another important thing is the difference in terms of billing when you have to deal with child devices. You pay for devices that are provisioned. So if you have provisioned both, so you have both the gateway device and the downstream device, you have to pay for all of them in terms of pricing model, but you have all the amount of messages. So the message limits is the sum of every single device, downstream device and gateway device. And if you choose to only provision the gateway, and so all the downstream devices are not managed by IoT Central, but uses the gateway to pass the data to the cloud, you will pay only for one device, but the amount of messages is related to only one device. And so probably you will pay for extra messages because you have the sum, so the aggregation of every downstream device message amount. Third thing, message. I count a message when I have a telemetry, but when I have a read or update communication or a command. Okay, so every kind of operation, so synchronization of properties, commands, um, are messages, so are built. Okay. Instead, if you want only to explore past data, so within the 30 days of retention, you have not to pay for them. Okay, in terms of expandability, so expansions, there are three main areas, okay, that we have to consider if you think to the architecture of IoT Central. So you can have a sort of expansion of IoT Central in terms of edge computing. So device connectivity, data, and compute before ingest data natively into IoT Central. Another case of expansion is extract business value from the data that you have acquired into IoT Central. And so, as we said before, all the capabilities in terms of export and in terms of store and analyze, so the usage of signups and so on. And the third area of expansion, okay, of IoT Central is in terms of applications that are connected through the API stack that is offered within IoT Central. The first area is regarding connection, okay, so connectivity. Imagine that you have, as we said before, two kind of devices. The first kind of device is persistent. So you have to maintain a network connection or a mechanism of reconnection, okay, in case the network is broken or not present in a certain moment, okay. In this way, you can have three kind of things. Downstream devices that are connected directly to the IoT Central and communicate with the IoT Central in terms of MQTT protocol or AMQP protocol. You can have a sort of aggregation, so an edge device, an edge gateway, or probably the most widely scoped case is to have devices that not persistent, that doesn't have a persistent connection. Okay, in this case, we have ephemeral devices. And so devices that are connected using a device bridge. Device bridge is sort of a container, okay, with an HTTP endpoint, and that endpoint it is a sort of adapter through which the messages can be acquired, and you can send those messages directly into IoT Central. You can find the device bridge project into GitHub, or you can expand that layer with preprocessing, so conversion of formats from probably a raw format into a JSON format or something like that. Device bridge is important to understand that the device bridge can be considered as a sort of bridge between an external cloud, so an external entire acquisition system that is deployed within a plant. For example, in large plants, you can have your private cloud inside the plant with all the infrastructure in terms of data ingestion, data analytics, web application, and so on. But in order to monitor some probe within the plant, you can use the IET internal system to forward some data to an external endpoint. In this case, you can use IoT Central in the same way, using the HTTPS bridge approach. Okay. So, in terms of customization, you can use two things, two layers, two kinds of solutions. You can perform a custom transformation and computation within the edge. If you have got IoT Edge, you should prefer to pre-process all the messages within IoT Edge and transform the messages internally and send the messages in the standard way, so following the IoT plug-and-play standard or your device template model. The second one is to perform customization or transformation during the device bridge. Okay, so acquire the data with the device bridge, but bring the data from the device bridge and transform, putting into a temporary queue, and then with the function resend to another or the same device bridge. So bring the data with a bridge, preprocess the data within a queue, send the data, the preprocessed data into another instantiation of another instance of device bridge that is already connected with the IoT Central. The second area of expansion is regarding extract business value from IoT data. So probably you have the most wide number of components within Azure services that you can use to post-process the data that is acquired in order to find out anomalies, find out trends, find out KPIs, find out action to be done within the plant, and so on. And in this visualization, we can consider all the call path data. So put the data with the continuous export into the storage and bring in the data from the storage and make some algorithm around that data, or transform the data into a data set for machine learning with, for example, bringing the data that is in JSON format and transform the data with the backfill properties. So stamping in every second all the current values of your process data, and then save into a CSV, for example, file, and send the data to another storage and use that data with the Azure Machine Learning Services to train a model. Okay. The second one is to stream the data out, and so use the streamed data to make some analytics using stream analytics, or send to ADX for telemetry storage. In both cases, probably the data that comes out from the data bricks, or comes out the continuous export that you can activate within ADX, all this data that is stored in a final archive can be used with Spark Pool or something like that within a Synapse in order to analyze and view data. So, in this slide, I would like to focus with you the role of APIs, because APIs permits to build up custom applications, probably using Power Apps or something like that, but are custom application in terms of workflows, managed workflows. Okay, so for example, the fleet operator and the fleet manager are two profiles within the fleet management. Okay, so not the device solution developer, not the device developer, not the system administrator, operators, but with two different levels. So operator, okay, and manager of operators that can use or you can build up the custom application for those kind of profiles, but you have to focus within the scope of their role, and so what they can do with the control plane API, so the management of devices or applications and so on, the data plane API, so access to the data, access to the settings, and overall with identity and access management, so the capacity to authorize um, companion apps, okay, or particular users, external or internal users. And so, for example, the fleet operator must manage device life cycle, okay, as we said, connectivity, troubleshooting, and so on. And using the control plane, you can provision, you can build up an application that calls control plane APIs in order to provision, manage, and control devices without accessing to the IoT Central. Or using the data plane APIs, you can access data, okay, that is sent from the devices in terms of state of connection, errors, and so on. Okay, the fleet manager, for example, can have a sort of top-level visualization on top of this data, and can have so a dedicated pool of dashboards in another application, okay, using the same control plane APIs and data plane APIs. I would like to remind you that in the IoT ecosystem, often in my experience, I've found several companies that already have custom applications, and they would like to enrich those applications with native IoT services. And so you have to understand which are the APIs, so which are the capabilities you can give to your final customers in terms of integration within their already owned apps. Yes, this is another visualization, okay, of how can be managed an application that is divided into two main roles. For example, if we plan to manage a fleet, a real fleet, so a truck fleet in this case, probably we have to differentiate. This is only an example in order to focus how to divide interfaces. We have to divide the point of view, first of all. And so, for example, this is an example of the fleet operator. So you select the device, and then he's got a sort of visualization of the real asset that is managed with a device connected to IoT Central with the probes, so the main values that are transmitted from the device. So in terms of, for example, instant velocity or last engine engine scan for errors, or temperature, fuel level, and status of the device. Okay, so it is movement, it is in an idle state, so it is started, but is not the GPS position doesn't change, and so on. Okay, and through this visualization that is vertical for each single asset, probably you can send some command. For example, a reboot device, or send a dump request in order to have all the instant diagnosis, okay, of the asset, and so on. On the other side, the fleet manager must have a sort of cross-asset visualization, and so probably he have to manage all the local to that application and to that tenant, all the authorizations in terms of new drivers or new users of the application, okay? And probably the fleet manager should have information about the maintenance status, not the GPS position, but the maintenance status or the current operation on each single device. Okay. In order to focus better with this example, it is only example, but it is useful from my point of view to find out the real meaning of IoT Central and what you have to do around IoT Central in order to complete the solution, okay, thinking to the result, not to the technology. And so, for example, if your job scope is to make bulk updates, firmware upload, and so on, because you have to fix something, probably you have to manage better in your custom application, okay, all the jobs. And for example, you can divide the job. Okay, it's important to annotate that. And the jobs can be divided into multiple batches, and so you can assign to a particular pool of asset a particular update. Remember when I said learn the right mindset of fleet managers. So put the updates locally to a geographically identified point in order to test if your updates are good. And probably in this case, you have to put the updates in the nearest location to you, because if you lose the device, you have to go physically to the device. In this case, yeah, you can go on and so view all the steps in order to proceed with a well done update, and with a rerun job functionality. You can see all the failed updates and optionally rerun those jobs. In this case, my hint is to have a clear vision about the firmware releases, because when you deal with physical assets, you have to manage not in the same way the same update. So you have firmware releases that are under your layer of software within the device, every device, and so probably you have some slightly different approach to the firmware, and probably your updates must be related to those or certain version of the firmware. Second hint, pay attention to last known values, because you have to deal with disappeared device. So when you have to automate alarms in terms of date time of the last value sent. Another hint is to periodically export the device lists, because device groups in reality are dynamic, and membership history is not covered about in IoT Central. Imagine that you have, for example, a black box in a car, and that black box is installed in a car. Imagine that in the first stage, black box, so the device ID is related to an organization, so to a customer. But in the history, probably that black box is changed because it disappeared, and so the maintainer choose to change that black box, and so associate a new device ID to the same car, to the same car plate, okay? And you lose all the history of the car, not only of the device. So you have to consider that the devices are changing during the time, but the things remain the same. Okay? So you have to find a strategy in order to relink all the history of the data with the correct thing. And another important thing to do when you manage a fleet, you have to annotate everything you do within IoT Central and within all the other applications, because it happens that you make some error and you have to find out which is the list of a single activity or operation that you have done in order to compose a sort of device dossier. So a sort of list, historical list of all the operations that caused something wrong within your fleet. And another important thing is to make your own fleet diary. So the list of all the jobs that you have done during your activity, during all the history. I don't want to bore you with other things regarding fleet management, but let me let me focus other 2 points. Um, Remember that you can abort on condition some job. So if, for example, a job is not done correctly, you can rerun, and then choose to abort on a particular condition the application of a job to a certain device. Please annotate that, okay? Because it is not done by IoT Central. And another important set of small caveats are you have only 30 days of history in the job, okay, history. And so my advice is to keep a sort of diary of your historical job that are done and with all the errors, okay? And another important thing is important limitation is that the device groups are not dynamical, or sorry, in the job session you can select a subset of devices within a device group. So please don't consider the device group as a sort of static group, because probably during your history you will change the device group of the relationship between devices and device groups, because you will deal with several jobs that are that are related to a different group. Okay. Um, Remember that you can't export automatically logs on storage, and that this is important. The job scheduler is related to your time zone. So think about the real application of an update. Okay. For example, if you have a fleet of cars that are in movement and that are corporate cars, so they start probably every morning to Monday to Friday from 8 p.m. in a certain time zone, okay? And you want to update their device. Please do not during the hot period. So during, for example, the first traveling time. So from 8 to 8:30. Okay, during their first usage. Probably you have to deal with a different time. So at the end of the day or prior to the start, prior to start the machine. Something. So think about the real daytime, or the real time zone in which the device will do the update. My advice is, if you can, is to manage the application as a sort of attribute of your job. So when you send a JSON to a device with a particular action, explain better in that time zone which is the right date and time in which the job will done physically. Okay, but within the period of job monitoring from the IoT Central side. Um, Remember that you can run multiple jobs at maximum 5 from an IoT Central application. Regarding monitoring, oh, all modules, for example, in IoT Edge, has got the possibility to send metrics. Okay, there is a news about it because in the past the option was to send from every single module logs directly outside. So, for example, calling HTTPs from every single module. There is a news, so there is the possibility to use a sort of metrics collection module that is a sort of a Prometheus compliant module, okay? And you can have the option of sending directly to the IoT Central logs such as the telemetry, or you can use the metrics collector module, and that can acquire locally all the metrics and send not to IoT Central but to another entry point. And this is, in this case, the entry point is the properly known entry point, so log analytics. Okay. Uh, I don't know exactly which is the right strategy. In my business company and my experience, log analytics is a shared component between the operators that monitor all the fleets and the development staff. So my advice is to send the logs in the proper location, so to log analytics, but do a sort of page or set of dashboard within log analytics that are free to be consumed by development staff. Or if you can, I don't know if it is possible, you can incorporate, so make a sort of inclusion of some tile within IoT Central that is coming from IoT from log analytics. So bring a dashboard into IoT Central and expose an external point. Try it. Remember that at the edge you have a sort of Prometheus gateway or something like that. So as a sort of Prometheus gateway, you can have your endpoint, and so you can double check locally that endpoint, asking for the page, for example, or asking for an HTTP 200. Okay, nothing else. This is an important question: how to name, how to make the right naming when you use modules, for example. And probably these are some tricks, some tips and tricks. So we can discuss about it. In my opinion, you have to include, so prepend some name in order to identify the origin of the something. Okay, so for example, include the module name at the beginning of a metric. So module 1 and then metric, in order to have a better set of better readable, okay, set of attributes. Or another important thing include the application name or the device ID or the module ID in as labels. Okay, you can use labels in order to describe better the metrics. So when you deal with logs or when you deal with attributes, it is better to include which is the origin. Okay. In this way, you can target better your log search. Another important thing is to how to enable the standard logging. So it is a module. Okay, so within IoT Edge, you can to download the Azure IoT Edge metrics collector, and from the workbooks point of view, you can activate particular workbooks that are already done from Microsoft, and you can associate them to your modules. For example, this is an example in which you can view your edge device and all the modules with the status of every single module. Very useful from my point of view. Okay. IoT Edge. What are the responsibility of an edge device? An edge device has the most important responsibility from my point of view, because you have to deal with activation, with the device management, with health monitoring, with configuration management, with the remote updates, with the processing finite state machines in terms of command processing, filter aggregation, extension, etc., 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 and temporary buffering or long time retention. So a lot of things. And the relationship in terms of activities are divided into 4 families. So telemetry, so device to cloud, inquiries, so requests from devices that are looking to something, firmware update, or a list of commands, or a list of double checks, or a list of logs that are that must be sent as a dump, and so on. Notifications. So I have to, for example, I want to notify my change of state, my status that is changed to other devices, child device, or to the cloud, and so on. The opportunity within IoT Edge are multiples in terms of technology, because you can use many Azure services within IoT Edge. And so you can use stream analytics, cognitive, Azure functions, or whatever you want if you have a container. So imagine that an IoT Edge is a sort of private local network. Within you can have all the Docker containers you want exposed with their own their own TCP port, and you can connect all of them in the classical way. So call the local address, so the name of the container, colon, then the port. Or you can use a job as a sort of dispatcher, okay, of input output between those services and the applications, so IoT Edge modules. You can use local storage, so local blob storage, and you can send all the synchronizations in terms of local storage to the cloud. Or send the messages using MQTT and MQP to IoT Central in the classical way. Okay. Remember that you have to consider device twin capabilities in order to maintain up to date all the device information in terms of gateway device or gateway and downstream device.
important argument to focus is to connect correctly, to connect properly an IoT edge to IoT Central. So, first of all, the desired approach is the connection using the device provisioning service. So the DPS connection based, not the symmetric key or other options. But I would like to point out some important feature regarding the relationship within the device model template that you can find into IoT Central and the capabilities of the device manifest that is used to deploy all the modules within an IoT edge. So which is the relationship? Imagine that when you create a device template, you can choose the option to create a device template based on IoT Edge. In that case, you have to manage the edge deployment manifest, okay? And so you can configure for every module within your IoT Edge, you can define all the properties and all the telemetry attributes, okay? And so you have got the possibility, okay, to upload your IoT Edge deployment manifest, select manage, the the button, okay, manage interface, add all the properties, all the capabilities, and then after that you can have all the informations about connection. As I said, when you define an IoT Edge device, selecting the IoT Edge template, okay, you can click connect, the connect option, and on the device connection, you can select the scope ID, the device ID, and the primary key. So these values, okay, must be used on the device side, so within your local IoT Edge configuration, in order to enable the DPS connection. So first of all, define your device template, choosing IoT Edge, the IoT Edge type. You can define module by module all the properties and all the telemetry attributes. After that, you can create the IoT Edge device, selecting the IoT Edge template, and clicking the connect button. You can observe all the information regarding the connection. So ID scope, device ID, and primary key. Then you have to set the DPS on the edge. Okay, so access to the edge device, edit the configuration file, the config.yaml, and comment the symmetric key connection, that is the standard one, okay, and activate the DPS based connection. And so obviously the global endpoint will remain the same, and so you have to add only the symmetric key, the scope ID, and the registration ID, so the device ID. Regarding device modeling, we have to say some things, okay, in order to deep dive a bit into that argument, because IoT plug and play, okay, is the way in which you can model your device and upload your modeling into a common repository. And the benefit of IoT plug and play is that you can plan and develop your solution without worrying about the morphology of the messages. For example, in order to create a device model, you can use IoT Central, as we usually do the first time we access to IoT Central. So use IoT Central to create a custom model from scratch. Okay. So attributes and so on. So you are defining your own device. But you can define your device model in other two ways. The first one is using the DTDL file that you have edited with the Visual Studio Code plugin. But there is a third option. So you can select from a sort of device catalog, okay? And this device catalog, it is a sort of repository of IoT plug and play compliant devices. So you have to deal with the IoT plug and play in order to make your own device compatible, such as other devices, okay, that are already compatible, and you can file those devices already done, already ready, okay, to be imported from the device catalog. So some hint or some definition about IoT plug and play. First of all, when you deal with plug and play, you deal with persistent connection. So you can do IoT plug and play properly. Sorry, if you have an ephemeral device, so with the device bridge on top. So first of all, ensure that your device is using MQTT or MQTT over WebSockets and so on. Okay, you use the TDL to compose your JSON file. You update your device or your module in order to complete the device connection using the model ID. Okay, and after that you can implement telemetry and so on. Using the mobile app, okay, you can test all the telemetry flow, all the properties interchange, and other things. Okay, and you can test all the monitoring pipeline, so retrieving logs, for example. There are two broad categories in an IoT solution. Okay, there is a sort of solution that works with a known set of models. Imagine that you have a sort of device catalog with various, for example, smart meters, and you can use them to connect with the same solution. Right. Another solution, it is a generic solution because it is a sort of context-based solution. So water management, for example. So water management is not water management with X, Y, Z devices, okay? But is a generic water management solution. And so you have to deal with a not well-defined device, but you want to acquire those kind of devices in order to implement your context-based solution. And so in that way, the IoT plug and play is a mandatory. And to use IoT plug and play in a solution, so you have to identify the model ID, okay, the unique model ID of your plug and play device in order to share, okay, which are the compatible modules that can be used as devices, source devices, linked to your application. Or you can do the contrary when you plan to develop your solution. First of all, define which are the modules IDs that are compatible, and retrieve the model ID and model the solution based on that or those models. Um, what is device model management? Is the way, okay, they are building, the PG group is building a sort of official flow in order to validate all the DTDL models that would like to be a standard model. So when a device is a compatible device, fully compatible device with the IoT plug and play. At the moment, there are two ways, okay, that can be used to manage device modeling. There is a sort of public device model repository, and so it is a public way to diffuse, okay, your plug and play model. And so if you want to sell your devices, you can develop your own device model and upload it to the public DMR, device modeling repository. There is a official validation by Microsoft, and your model is immutable, so you can update with new versions, but you can modify that model. And all the consumers of that model can consume that model in an hyperscale infrastructure, so the IoT Central infrastructure. Another way, if that if you want to use your own models, and so you don't want to share with the other people your models, but you want to manage you want to manage all the versions, and probably you want to link the devices, okay, and the IoT Central to the right repository in order to have all the capabilities, okay, of a device model repository. And so you can do that, but you have to build up a sort of infrastructure in which you can install the project, okay, because DMR is a project on that you can download and replicate, okay, it's a project on GitHub. And so you can change your URL, DMR URL, in order to access to your DMR, and so retrieve the device models from your DMR. When we talk about modeling, we talk about two steps or two kinds of model. A simple model, so it is a sort of unique model with no components, so no subdivision of functionalities. For example, a car can be considered an object or a pool of objects: the wheels, the engine, the chairs, and so on. So there are two types of model. The first one is no component, so a model in which you can declare telemetry, properties, and commands in a flat way. Probably this kind of model is good if you don't want to reuse parts of your device, because it is a simple device. But if you want to embed multiple parts in one unique, not small, okay, device, you probably, and you want to reuse some component in other device version, small, medium, large, or more complicated, less complicated devices, you can use a model composed of two or more interfaces. The term interface is a sort of a subset of telemetry properties and commands that are related only to a component, so to a part of the asset. And yeah, in this slide, you can see how the JSON with the DTDL changes. It is a sample in the contents section. The schema is not a property, but is a schema of type component, and so you declare the child DTDL file. So imagine that with a simple model with no components, you have only one JSON. Instead, on the other side, when you have a more complicated device, so divided into components, you have got a main DTDL file and other DTDLs that are linked together, okay, as a sort of child. But you can link the same child to one or many big devices. In this slide, I would like to point out some important feature of the syntax modeling. You will find some term such as DTMI, okay? The DTMI is a prefix, okay, in order to identify a model ID, a model identity, and the type the body of the DTMI maps in a sort of for the Java programmers, okay, it was the package in Java. So speaking about the file system, it is a sort of folder, subfolder file. In this case, for example, it is the folder com contains a subfolder example that contains a file that is called thermostat.json. And one, okay, after semicolon, one is the version of the model identity. After that, we can say that the model is structured, okay, into a set of interfaces, so components, and every component has got properties, okay, telemetry, and commands. So, which is the model life cycle? You've got first develop models. How? Two ways. Web graphical UI and dump to the repository, or VS Code and validate. Second, public, okay. So expose and share models that you have developed into public or custom or a customer property DMR, okay. And after that, in your code, so from the device side, when you have to identify your device model in order to do dot get telemetry or dot get properties or dot set command methods. So when you develop a solution, okay, with IoT plug and play, you have to instantiate the model's repository client, and in that way you have to point to the correct URL, so the public or your private URL. After that, you have a sort of digital print of the attributes, telemetry, properties, and commands. And so you can consume models within your application using your device twin, digital twin client. Okay, this was due to the fact that one of the three possibility of extending an IoT edge, an IoT central solution is at the edge. But now we have to talk about the extensibility model after the IoT Central. So, looking at the right side of this graphic, we already said that we can export data to transform the exported data to enrich with a fact and dimension model data warehouse. Or, for example, we can export data to merge plant data with company data or other things. Or, for example, derive some derived data and store that derived data into the dataverse in order to enable business applications. Okay, so in Dynamics or Power Portals, Power Apps, and so on. Or you can do your own business application, obviously. Thinking about the higher level, okay, and at an higher level, we can integrate all the data that comes from IoT Central with several kind of services. So Power Platform services or Azure services or Azure Data services. For example, the first one is to integrate with Azure Data Explorer. 2 minutes on Azure Data Explorer. Data Explorer is a big data analytics service that is built to offer a complete tool, an end-to-end tool to acquire data, modified telemetry data, modify time series data in order to build up new series, and you can stream out data to storage or other things, or you can use the content of this time series or columnar database with other services on top, for example, Power BI or Grafana, or connect to other services, ADX, for example, with a ODBC connection. Okay, you can navigate as a sort of such like a SQL Server. And this is a not complicated but complex service. In this way, you can use all the ADX capabilities to ingest all the long-term data that comes from IoT Central, okay, and view the data and apply anomaly detection and other things, other functions in order to explore data. You have to deal with Custo as a query engine. It is very, very, very powerful. You have to learn it. And but you can use ADX as a sort of source in order to running your own Jupyter notebooks using Python, or there is a complete SDK for R. And it is very simple to be activated. It's not so cheap, but if you want to deal with long-term data or with the telemetry in general, you have to deal with it. There are no other ways that are sustainable. Okay. Imagine that with the ADX, the raw data enters. Okay, so for example, a file that is exported from IoT Central, and then with a sort of function, a sort of script within ADX, that is called update policy. You can get the source table data. For example, the data that is stored as is in an initial temporary table, and after that you can create new tables that are filled at the same velocity, okay, of the row table filling. So when you fill the row table, the magic is that the update policy starts, and it updates the derived table, the target table. And so, for example, you can have a generic stream of data with all the logs, and using a function, you can fill up well-divided table. For example, a table for a subsystem of a complex asset, or a table with all the power management variables aggregated into, in order to have a sort of energy context, or a quality context, or an asset maintenance context. So you can use the update policies to fill out target tables that are divided into multiple contexts, or divided into multiple sub-assets. Okay? So, simple. Export destination, event hub. Event hub is a direct input, and after that you can use within an update. You can use the update policies, the update policy within ADX, and then you can, for example, check with a logic app, check some query, okay, in order to trigger something. This is an example with an export destination such as Event Hub. In my personal opinion, probably Event Hub is a good choice if you have a small amount of events. Okay, if you want to ingest all the telemetry, probably the best choice is to use blob storage. That must be considered when you use IoT Central as your IoT ingestion focus point is Power Automate, obviously, because there is a dedicated connector to Azure IoT Central, and with this connector you are not you can dispose of all the data. You can use all the data, sorry, in order to trigger actions. And probably you can use Power Automate to connect to AI services easily, okay, your IoT data. So the approach is based on the low code and drag and drop tool, okay, in order to do repetitive tasks, okay, not only alerting and so on, but repetitive tasks can be done with the Power Automate. Probably the most interesting point is to use Power Automate to trigger AI services as webhooks that are already active, or you can easily activate them into Azure. So the capabilities of Power Automate, the capabilities of Power Automate are mainly three. So you have to automate workflows in order to bring the data from one service to the other. And another capability is to make RPA, so automate processes, okay, with on-premises software, for example, or other business line software. And the third one is to integrate AI models into your workflows. So recognize defects from an image that is sent as a sort of file upload, because there is something wrong, okay, with the production. If you deal with industrial IoT such as me. And from the Power Automate point of view, in general, the Power Platform, okay, is good in order to use over 3,300 connectors that are available to connect your data with already done applications, okay, or other software as a services. But the main workflows that you can do are based on what we call as power apps, okay, in order to have interfaces, or logic apps in order to have yeah, workflows of more than one service. And but overall, you can approach this kind of this kind of solution based on low code and based on Power Automate to build your own custom connector. So, for example, you can build up a custom connector in front of a logic app or in front of a Power Automate flow. And probably in your custom connector, you can insert your own logic and your own models. And so you can link something that is special, something that is custom to a standard software such as IoT Central. In my opinion, the best tool to use after IoT Central is to deal with the Power Apps portals, because there is a plethora of external users that don't want to pay for have a Dynamics license, for example, or a Power Apps license, but want to have public information about things, okay? And probably the right way to do business with the low-code application is to use Power Apps Portal, because you can have not authenticated or enable authenticated users, so powered users, to deal with their own devices, or to deal with the environment devices, okay? So imagine a place with waste management, water management, charging points, traffic, weather, a huge amount of environment aspects that can be condensed into one digital place, okay? You can integrate chatbot, other things. It is important to know how is the pricing model of Power Portal, because it is not the same of Power Apps, because your units, okay, are not users, but sessions of 24-hour logins for authenticated users, or the number of page views for not authenticated users. And so it is an affordable way to try IoT-based value-added services. Okay. From the internal point of view, it is obvious that you can use IoT Central to fill something that is regarding connected field service. It is obvious. And so you can use Power Automate to or Logic App to connect data directly to Dynamics 365 to inspect, for example, some device reading within the work order section of a maintenance. Okay, this is obvious. This, for example, is a way in order to do the things that we already said. So, for example, bring data, exporting data into an event hub, configure the event hub as a sort of direct input in Stream Analytics, and expose a Dataverse-based function with the logic apps, and call the logic app using the HTTP endpoint. And so configure the output of the Stream Analytics using the API endpoint of the Logic app in order to insert something into the Dataverse. So, and this is the last slide. Sorry for the time, but it was very complicated to summarize a lot of concepts into one only session. My message is that IoT Central is not a toy. IoT Central is the ace up your sleeve in the 99% of the use cases. You can manage it very well. It is a very flexible way if you use some approach. For example, basically the DTDL approach, model first approach. You can deal with your own custom devices. You can use your device bridge if you have ephemeral devices. It's not a problem. But consider that your application in IoT Central must have a well-defined backend, okay, made of device template models, rules, and so on. And on top, another kind of developer must think to personas in order to build up vertical user journeys, user experience journey, okay? But it is not the end of the data story because the data comes out from IoT Central and can go outside in order to offer to other people other services. So you can use IoT Central as a fulcrum in order to, for example, with Power Automate, send data to data analysts, okay, offering a data platform-based solution, so signups, analysis services, and so on. Or you can use some derived information, some KPI, some last known value to fill up services and after-sales department applications within, for example, Dynamics 365. But you can make value to other customers, to other users, sorry, that probably are not your customers, are only external users at the moment. But if they can find value in your IoT, they can be your next customers. Okay, and so you can use Power Portals to define or to try to define new business. Okay, so use Power Portals to define the initial version of many applications in order to retrieve value from the data you have acquired with the IoT Central. Thanks for watching. Thanks for the patience. Sorry for my English. I hope that you've learned something more about the right usage of IoT Central. Bye bye, guys.